When we create pointers, we make them point to different kinds of things. So a character pointer points to a single byte of memory, enough to contain a character. An integer pointer points to the first of 2 bytes of memory. Now, we decided earlier that short ints were actually 2 bytes and normal ints in our computer were 4, and it depends on your computer, your implementation, how long those actually are. But the compiler will keep track of that for you, how big a character or an int or a short int or a long, doubles, floats, all of those, how big those things are. A pointer itself also has an address because it is a variable as well. So there is such a thing as the address of a pointer, and then you can get the address that is stored in that pointer and then go to that place in memory and get the real value out of the piece of memory, just like we have our hello world spread out here. Let's take a look at creating some pointers. And here's our normal variables. We know how to do this. Here's integer x is defined and then set equal to 1, initialized. And here y is defined and initialized to 2. And z, our little array of 10 characters, it's defined here, but it's not given any initial value. Now this is new, and what is new is this asterisk right here, this star. We have an int space star IP, and you'll see in other versions of C, and even in normal C programming sometimes, people will write int star and then a space and a variable. They want the star in their description closer to the type to show you that this is a pointer to an integer and then the name. Personally, I grew up learning to put the star next to the variable name so that when I see this together, I know that this is a IP, is a pointer to an integer. So that star IP, that star says that IP is going to be a special size. It's going to be big enough to hold a pointer, which is an address in memory, and that pointer will point to an integer or 2 bytes. Now, if we're going to use IP, down here we can set it equal to the address of x. That's how you read that. Remember, we created x up here. It's an integer. And now down here we're going to get the address of where x is stored in memory. Address of x. That's how you read that. So we'll take the address of x, where it sits, and put it into the IP pointer variable that we created up here. So now IP points to x, points to this variable here, where it sits in memory. Here we can say that y is now equal to the contents of IP. It's the same asterisk, means a very different thing because of where it's being used by its context. This is called dereferencing. We are dereferencing IP. So what happens? We go to IP, which is a variable in memory. It contains an address. We get that address. We know that that address is where x is located. Then we go to that place in memory and get the thing that's in that place in memory. We know that to be a 1. This says that y is equal to the contents of IP. We know that IP is set to equal to the address of x. So this will take what is in x, which is a 1, and put it into y. All right, that's what's happening there. Be careful of the asterisk because it changes use depending on the context. Here we say the contents of IP is equal to 0. That is exactly the same as setting x equal to 0 because we are again dereferencing IP. This does not set the address of IP, the content of it, equal to 0. This asterisk says go to IP, get the address that is stored in there, the memory location, go to that memory location and put a 0 in there. Same as if we had said x equals 0. All right, you see the difference? Now here we are saying that IP equals the address of z sub 0, and that's the first element of the array of 0. So IP will no longer point to x. It will be changed. X will not be modified because we didn't dereference. We didn't put an asterisk here. We are saying that IP will now be equal to the address of the first element of the z array, just like we said IP is set equal to the address of x. I hope that makes some sense. We're going to be seeing a lot more of pointers and arrays and addresses over the next several videos, but this is absolutely critical that you understand how memory is broken up in the computer, single bytes. Each byte has an address, and pointers are used to contain those addresses. And then the asterisk, the dereferencing character, is used so that we can get to the values pointed to by the address locations that are stored in the pointers. All right, quite a few topics there. Watch this video again. Refer to your K&R for some other examples, and hang in there. We are going to talk more about this as we go. All right, but this is critical. And if you understand your computer at this level, you will be able to write much better code and have a much better understanding of how the machine works and why it does what it does.